Number 1, find the equation of a parabola that has a focus of 3, 4 and a directrix of y equals 8. So the first thing we need to do is sketch a picture. I have a focus of 3, 4, so that's in quadrant 1. There's my focus of 3, 4, and a directrix of y equals 8. 3, 4, 5, 6, 7, 8. Or close enough. Move that line down. So there's our directrix of y equals 8. A parabola is a set of points equidistant from the focus and the directrix. So this distance here, well, that's y equals 8, is 4 units. Then the vertex is in the middle. So the vertex is at 3, 6. The vertex is at 3, 6. And I know this parabola has to open downwards. It's a concave down parabola because the vertex of the parabola is there, and it needs to open away from the directrix and protect the focus. The focus has to be inside of the parabola. So there's a sketch of this parabola. It's concave down, and I'm going to pick my favorite point over here, x comma y. And we know by the definition that the focus to the parabola is the same as the parabola to the directrix. The distance from the focus to the parabola is the same. Those two distances are the same. So we set up the distance formula. We say the square root of x minus 3 squared plus y minus 4 squared, that's the distance from the focus to the parabola, is the same as the distance from the parabola to the directrix. Well, let's figure out what point this is here. I know it has a y value of 8, and it has the same x value. So that point is x minus x squared plus y minus 8 squared. Well, if two square roots are equal, their insides have to be equal. The radicand of the square roots need to be equal. X minus x is 0, so we're left with y minus 8 quantity squared. Because I want my answer to be in vertex form at the end, I'm not going to touch that. I'm not going to touch that x minus 3 because I want my answer in vertex form. So y minus 4 squared, set up a table, do something to actually multiply that binomial by itself to get y squared minus 8y plus 16. And that's still there. Equals, multiply that out, y squared minus 16y plus 64. If you need to see where that's coming from, make a table, write it twice and use the distributive property, do something, use the identity, do something so that you multiply that out correctly. There's a y squared on both sides, so I'm left with x minus 3 squared minus 8y plus 16 equals negative 16y plus 64. Well, I want to get my y's on one side, I want to get the y on one side of the equation, and I want to move that 64 to the other side. So I have x minus 3 squared. 16 minus 64 is minus 48 equals negative 8y. Well, finally, to get y by itself, I'm going to have to divide everything by negative 8. And we get a final answer of negative 1/8 x minus 3 squared plus 6 equals y. That is the equation of the parabola. Let's see if that checks. Let's see if that makes sense. It's concave down because the a value is negative. I shifted it right 3 and up 6. Right 3, up 6, there's the vertex right there. So this is the parabola. This is the equation of the parabola that has a focus of 3, 4, and a directrix of y equals 8. All we have to do is make this picture and then use the distance formula. Number 2, find the equation of a parabola whose directrix is x equals 2 and focus is 4, 1. So, sketch a picture. I have a focus of 4, 1. There's the focus. And I have a directrix of x equals 2. Well, x equals 2 is a vertical line. That's almost x equals 2 until I drag it over. So, clearly this parabola is going to have to open sideways. The vertex is in the middle, and the parabola contains the focus. So, this parabola opens sideways. So it's not going to be a y equals x squared parabola, it's going to be a x equals y squared parabola in the end, because it's not going to be a function. Doesn't matter though, because we still find the equation the same way. Pick a point and call it x comma y. This distance, well, the focus is 4, 1. That distance, well, let's figure out what that distance is. X minus 4 squared, your change in x squared, plus your change in y squared, is the same as that distance. Those two distances have to be congruent. Well, what point is that? What blue point is that there? Well, I know the x value has to be 2, and I have the same y value. Equals the square root of x minus 2 squared plus y minus y squared. If two square roots are equal, their radicands are equal, so we can basically square both sides to get rid of the square root. I get x minus 2 squared plus 0. Now, here's the thing. I'm not going to touch the y minus 1 squared because I want my answer to be in vertex form. So I'm going to actually expand out the x's here because they kind of have switched places. In the previous one, we didn't touch the x terms. Well, in this one, because it's a sideways parabola, we're not going to touch the y terms. So you get x squared minus 8x plus 16 plus y minus 1 quantity squared equals, square that, and you get x squared minus 4x plus 4. Notice how I have an x squared on both sides. Those, I can subtract that out. I want to get my x's on one side and my numbers on the other side. So I'm going to add that 8x over, subtract that 4, y minus 1 squared plus 12 equals 4x. Divide everyone by 4, and I get 1/4 y minus 1 squared plus 3 equals x. So this is not a function of x, this is a function of y. You plug in a y value and it tells you the x value. Did I shift it? Did I shift my y's up 1 and my x's up 3? Well, my y's got shifted up 1, my x's up 3, so that is the vertex. It's weird because we're not used to doing the transformations this way, but it still works out the same way. Again, this is something that I think will not be on the Regents exam, but I always want you to be comfortable seeing something because it's just the same thing, it's just shifted the other way. It's just rotated at 90 degrees.